Okay, so let's get started. So I told you to try to work on exercises 6, 7, and 8 at home. And I will try to do them, all 3 of them, but we will start not with number 6, but with number 7, okay? Because number 6, I need a new data set, a new back file that I need to connect to the, and for that I need to connect to the camera. And I'm not sure if the camera will not once again something with my computer. So let's first start with exercises 7 and 8, and then we go back to 6 if we have time. So the idea is that for ROS, it is an ecosystem. So it's a complete way of doing things where you have some standards. These standards are the messages that are passed between nodes. For example, if you want to pass a message from a laser scanner, you are not going to come up with a new message. You go and you search for ROS laser scan messages, right? And laser scan messages have already been defined, and you can just use this information, populate the fields of this message with whatever you want, and you will be publishing or receiving a laser message, depends on what you're doing. And this is true not only for this kind of sensor, but for many sensors. For example, you have for images, initial measurement units, lots of stuff, satellites, GPS, blah, 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 lots of sensors. And not only for sensors, also for basic stuff like what is a string, what is a float, blah, 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 this kind of stuff. So ROS has a lot of standards for messages. You should create a new message only if you cannot find the proper counterpart in the already defined ROS messages. Okay, so don't start creating custom messages if you don't need to. In any case, we are going to study now in this exercise 7 RVs. RVs is the ROS visualization, and it allows for visualizing information. Not only visualizing, but mostly visualization. So RVs is an application where you can see a 3D window, and in this 3D window you can put lots of information, sensor data, robot models, whatever you want, as long as it's 3D. And then you can, RVs is also completely configurable, so you can configure RVs to show whatever you want him to show, you want it to show. So you can show images, not in the 3D window, obviously, but in a separate window. You can show point clouds, you can show laser scans. We've seen it last week, some examples. Now, what if you want to show something in RVs that is not standard, that RVs is not prepared to draw? So the solution RVs has for this is, where is it? Here. Is the visualization, is the marker message. So we can send a message to RVs, which is a general drawing message. It's a marker, and this marker can be one of any of these things: an arrow, a cube, a sphere, a cylinder, a sphere list, some points, whatever, some text, okay? So you can pick up a marker and populate this marker message, send it to RVs, and it will draw whatever you ask. So this exercise 7 is all about doing something like that. We want to create a node which will publish 3 markers. One will be a green sphere, which is semi-transparent. Then we want to publish a red cube, and then some text. Okay. Well, let's start with the first one. So let's try to publish a green sphere. How can we do this? Well, as I told you, we have to publish a marker. So our starting point could be, let's say, for example, some example where we are publishing something. Let's go here to part. This one, for example, source. We have here a publisher server. Okay, so let's pick up this example. So first, I have to create a new ROS package. I'm going to do that. So in part 10,
In part 10, I'm going to do catkin create package, PSR 22 P2, that's part 10, exercise 7, okay? That's my package name. Then it's going to depend on Rust Python, standard messages, and also visualization messages, because we are going to use RV's messages. So might as well put it there already. Okay, so that's it. I just created the new package, which is this one in green. Okay. Now, in this package, I need to put my publisher example so that then I can adapt. So I'm going to put the publisher into the source, change the name to RV's publisher. Okay, so this is my RV's publisher.
You went to part 8, right?
Yeah.
What exercise?
Exercise 5, but it can be any. It's just the starting point. Well, I can do better than that. I will send this to the cloud, and you can pick it up from there. If you want, I can just push this. Starting part 10, E2. Okay. Yeah. Hello. Okay, so now we have the RV's publisher. This is just an example. So now we have to figure out whatever we need to do in order to change this to unique. Really, what I'm going to do is pick this one up and take everything away from it. So it's really, look, I'm going to take the initialization away of the dog. Yeah, I'm just going to have an initializer, an init. This is my RV's publisher, my node name. Then we will publish something which I'm going to call markers, or better still, marker. I'm going to publish a marker. And here we have to define the type of message that we are going to publish. So this type of message, in this case, is a visualization message marker type. Where is it? Here. No, not here. Here. Come on, not here. I'm lost. Okay, so like better like this. RVs, visualization messages marker. I don't want this, I want this one. Okay. So here's my visualization messages marker message. So it contains a set of fields, like the dog contains the field name and the age and the color. This will contain the header, the namespace, the ID, the type, the action, and so on and so forth. So it contains a set of fields. And we are going to publish this kind of a message, okay? That's the message that allows us to draw a generic object. So we need to include this. We need to say when we are configuring our publisher here in line 22 that we are going to publish this marker message. So our messages, these messages will be of type marker. And before they were of type dog, and what did we do? We said from PSR blah 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 dot message import the dog. So in this case, now we need to do from what's the package name? Visualization messages dot message import in this case marker, right? I can also take this dog name over. So now I've imported the marker. Here it is, okay? Now we move forward. We don't need any service, so take it away. Our execution will define the frequency, which now we don't need to take it from a parameter. Let's say it's 1 Hertz. And we have here where we need to do 2 things. First thing, we need to define the marker, the sphere marker, okay? And then we need to publish the sphere marker, sphere, right? So these 2 things are the ones we need to do. So for the publication, we can take this, let's call it marker, and now we have to define here our marker. Like we did before in the dog example, if we have a message of a dog, we have to create dog equals dog, dog, like this. So this is the instantiation of the dog variable, that's the dog with the small letters, from a dog class, which represents a message, that's the dog with a capital D and the parentheses. In this case, it's the same. I'm going to create a marker from the marker class, which exists because I've imported it here. Okay. Okay, so I've created a marker. Now, what do I have to do with this marker? This is a variable that must be populated. So now I have to populate all these fields, or some of them, depending on what I want to draw. I have to populate all these fields in order to define what and how I want to draw. So let's start from the beginning. We have here a header. Actually, I'm going to look from here. Okay? It's the same, but with a different format. So we start from, these are just definitions, so these are not really fields. Only these are. So we start with a header. What is a header? A header is another message from rows. I'm going to open here. That contains a stamp and a frame ID. So the header is used to define what was the time in which this message occurred. That's the stamp. And where is the reference frame? What is the coordinate frame, the frame ID, with which the 3D data from this message relates to. Okay. So let's define the frame ID. We are going to say, so marker contains a header, contains a frame ID. And our frame ID will be, let's call it world. By convention, I always use world if I have nothing else to say. The world is like the reference frame. Now, what else? We go back. Time is not, the stamp is not important at the moment. Now we need to define a namespace. So marker dot namespace equals, let me call this my drawings. Okay, so namespace is like the namespace, a group of things of that group certain markers. So here's my namespace. Next, marker dot, what's next? It's the ID. ID. So ID is an identifier, a number for each drawing that you want to do on this particular namespace. I only have one drawing, so let's put 0 here. Next, actually, I'm going to do better. I'm going to copy paste this. Okay. Copy. Paste. And now I need to. Okay, now yes, now like this. Okay, now yes. So now we need the type. So that will be marker dot type equals, what is the type? So we can have things of different type. If you go here, the type will be, where's the type? Here. It's the type of object. So it depends on what I want to draw. So this is the type. It can be an arrow, a cube, a sphere, a cylinder, whatever I want to draw. Exactly. So we can either put here 2, or even better, Enrique, we can say, do you know, I told you, the fields only start from the header downward. This is not important, I said. What I meant was that these are not fields, but they are used to define values of the fields. So if you want a sphere, instead of writing a 2, you can just write marker dot sphere. Okay, this marker is capital M because that's the class. Okay, action. What is the action? The action is what you want to do with this drawing. You can either draw it if it doesn't exist, or modify the current drawing if it does exist, or delete. So this action can be one of both, one of two. So let's just type here action, and that will be marker dot modify in our case. Okay, marker is done. Now we go for the pose. So for the pose, it will be something like marker dot pose. And what is a pose? So we go down here and we see that the pose is, this is like a composed message inside. So the pose is a message in itself, like the header was, and we have to check what is inside the pose. So if we go into the pose here, you can see that the pose has a position and an orientation. So let's first worry about the position. So we are doing pose dot position. Then what's inside the position? Again, the position is another composed message, which is a geometry message point. Let's check it out. Geometry message point contains X, Y, Z. So if we want to define the complete position of the pose, we have to say marker dot pose dot position dot X equals 0, dot Y equals 0, and dot Z equals 0. Okay, so I'm just defining all the positions. And now remember that the pose, now let's go back. Remember that the pose also contains an orientation, which is, in this case, also a new message, which is a quaternion. If we go into the quaternions, you can see that it contains fields X, Y, Z, W. That's the definition of a quaternion. A quaternion is just a compact representation of a 3D pose, of a reference frame in 3D. I will not go into details, but we need to fill out the fields X, Y, Z, W. So let me just do something like this. So instead of position, it's orientation. And we have X, Y, Z, W. So I'm just going to do here the Y, here's the Z, and here the W. Okay. Okay, that's it. Now, we've done the complete pose, so we can take it away. Now we go into the scale. So what is the scale? If we take a look at the manual here, and if we are drawing spheres, it says the following. Okay, so if you want to draw spheres, scale X is the diameter in X direction, scale Y is the diameter in Y direction, and Z in Z direction. So by setting this differently, you can get an ellipsoid instead of a sphere. So we can create an ellipsoid. So do you know the movie Arrival? Everyone saw the movie Arrival? Yeah. So there was a giant vertical ellipsoid. So let's try to draw this. Well, you don't know. Most of you, I think never. So Arrival movie. Is it? Yeah. Images. Yeah. Like this, okay? This is only half one, but we are drawing a complete one, complete ellipsoid. So, what we really, so this, now we need to change the scale. Something went from here. Where's my, I'm lost. Okay, now I'm back. I'm back. So now scale X, Y, Z. If we go here, you can see that the scale, this one, is again a new information, which is a vector 3. So we'll go inside vector 3, and we see it contains an X, Y, Z. So let's define the marker dot scale dot X equals, let's say 1 meter. Marker dot scale dot Y, let's say 1 meter, and marker dot scale dot Z, let's say 4 meters, because we want this to be a vertical ellipsoid. Okay, so scale is done. Now we go into the color. Same logic all over again. So if we go into color, we can see that color is a standard messages color RGBA. Let's check it out. It will contain a field R, G, B, and A. Okay, so we just have to say marker dot color dot R equals, let's put the sphere gray. So let's say that R, G, and B are 0.2, each of R, G, and B, G and B. And now this alpha is very important. Why? Because it controls the transparency of the object. So I spent many days, a few years ago, wondering why I couldn't draw an object. what in fact was happening was that I was drawing an object and it was invisible because the transparency was 0. Okay, so be careful always to set the alpha different from 0, otherwise you will be drawing invisible stuff. Let's do it transparency 0.3. Yeah, go ahead.
Yes, the geometry and the Aula are always good to work.
Yeah. In this case, yes. In OpenCV, it's from 0 to 255. Well, look, they are float 32, so they should be from 0 to 1. Now, duration lifetime, I will not talk about it now. Also the frame log. These geometry message points and colors and text, we will use them next. So I'm just going to leave it here, okay? Leave them here, but for this case of drawing a sphere, we don't need them, so I'm just going to comment them. And now, in the end, after creating our marker and populating it, we just publish it. So this is running at 1 Hertz because the rate is configured 1 Hertz. Let's see how it works, okay? So if we go, what we need to do here, we need to create RVs, so raw store. Then in a new tab, let's create here, well, not really. Yes, better. This one goes there, a new one just to launch RVs. Okay, RVs is here. Now I'm going to put this one smaller. Okay, now for the RVs, we need to configure this in the reference frame world because that's the one we are using. And we have to, let me just delete all this stuff. We don't, just have this, let me do. Okay, so I cannot delete the images for some strange reason. Okay, now we have to run, so RVs is up and running, and now we have to run our own code. That will be ROS run PSR 22 P2 part 10 exercise 7, and we have the RVs publisher node. So if we press enter, nothing happens because we are publishing the information ROS topic list. So we are indeed publishing the
Do I have to give
I think
CH mod permissions to the file?
yes, if you can get it,
Okay.
if you want to execute it. But I'm doing something wrong because is it running? Yeah, ROS publisher, and I'm publishing a marker. Don't we have here a marker? RVs. Ah, okay, here it is. Okay. Okay, so it has an anonymous name. That's why it was so hard for me to find it. So let's take away the anonymous name. So anonymous false, so that it doesn't add these numbers in front. So now if we do it again, and we do again this, you can, well, with a clear better, you can see here now that we have here our RVs publisher / marker. So that's our marker. And this is being published. We just need to add, to tell RVs to show it. Marker, visualization marker, RVs publisher marker. Yeah, thanks. Okay, so now we have here our ellipsoid in gray and transparent. Okay, by the way, it would be nice if the ellipsoid is up, let's say above the ground. What do we have to do? We have to change the z coordinate. For example, let's put it at 2 meters. If we run this again, now we are showing this there. Okay. Okay. Next, what we want to draw next is a red cube in the center of the brings the semi-transparent sphere. Okay. So in order to draw a red cube, what we will need to do is to do this all over again. So we have to define a new marker. Diga?
No, I was going to ask a question because I had to write world in fixed frame because it wasn't showing up in the drop down.
What you're saying is that you couldn't drop down and find world. It's normal. I can only explain this next class. When we go to TS, remember the question and I will tell you.
From your Aula, you can write it words and.
It's not, well, what happens if you don't do, well, first of all, you should congratulate me because finally I understood what you said in English. Then, what happens if you don't fill in one of these fields? When you create the marker, what happens is that all these fields will be set to 0. So if you don't set the alpha, it will be 0, that means your object will be visible. Okay, next. The cube, draw the cube marker. So it's a marker, it's the frame ID world, it's in the same namespace, it's also drawing from me, and now we need to have a different ID, otherwise the cube will override the sphere, okay? So we need a different ID, let's say 1. Now this is a cube instead of a sphere, and we are also going to modify. Where do we set the cube? Let's say also in z equals 2. The scale should be much smaller, otherwise the cube will not be inside the sphere. It can be the opposite, okay, the cube, and the color should be red. So if it's red, let's put it something like this, I don't know, 1, okay, R1, so fully red, and then fully opaque. Okay, now if we do this, do you think something is missing? So let me resume what I'm doing. Step 1. Right. So I need to publish the first marker of the sphere. Right now I'm just defining the marker of the sphere. Then I'm second defining the marker of the cube. And then I'm publishing the marker. That means I will only publish the marker of the cube. So I need to publish the marker of the sphere also here. Okay. So this is step 2. Define the cube marker. Okay. So now what will happen every second, because we are doing this at 1 Hertz, is that every second it will say, okay, publish a message with the sphere, and then right afterwards a message with the cube. It will publish 2 messages in a burst. Okay, we run it again. Okay, here we go. We have here our ellipsoid with a red cube. Okay? Now, the third thing that is required is some text. Okay, so if you take a look at this marker, we can see here. Where do we see it? Here, there is a field called text, and there is a possibility to do a text view facing. So you can use a type of marker, which is the view-oriented text. And when you use a view-oriented text, only the scale Z is used, which specifies the size of the text. And then you can also use the color, the pose, and blah, blah, blah. So let's now, in step 3, define a third marker. This is not published to sphere marker, this is published, okay? It's a third marker. And this third marker must also be published, so I'm also going to publish it here. And now it's going to be not a cube, but a text view facing. Modify the position, let's put it a bit upwards so it's not in the middle of the sphere. So let's say it's at 4 meters tall. Yeah.
We don't check that.
Yes, we do. I was trying to make a trap for you. Then the scale, only the Z matters. So let's take away the X and the Y. It can be there, but it's not important. And let's say the scale, I'm not sure if this is a good scale or not. We will test. Then for the color, let's say that this is the color we want. Okay. And now we need to say what is the text. So now this field matters, the field text really matters, and we have to put marker dot text equals hello from space, right? This is an alien vessel. Okay, let's try it. Okay, so now we have the marker there, also with a 3D. Okay, so we have what we need. That's it. Now, diga aí. Não percebi.
My RGB values.
Share
I
it.
don't know what's the name of my screen.
Yes.
Because I'm using the same values as you are, but it is either much darker or red. And it shouldn't be.
Let's see. Can I see the code?
So this is.
Oh, RGR.
Oh. Sorry.
Okay, can I share mine?
Yeah. I thought I changed.
That's the curse of copy paste. Okay, so next, notice that, as I told you before, what we are doing here is we are going on every second, we are doing a burst by publishing instantaneously, almost instantaneously in sequence, 3 messages. One marker message of the sphere, another of the cube, and then the text. It doesn't really make a lot of sense to send these 3 messages separately. It's as if you have to send some cargo from here to Lisbon, and instead of sending it in a truck, which contains the whole cargo, you send 3 small cars containing 1/3 of the cargo. Okay, so if we want to convey all this information, visual information to RVs, we should send a single message containing everything, and that's what we can do with what are called RVs. Well, perhaps better here. RVs, visualization marker arrays. Okay, not this one, sorry. Here. So what is a visualization marker array message? Well, it contains only one field, which is a list of markers. That's it. So what we are going to do is a new code that will take advantage of this marker array and create a single message every second containing 3 markers inside and do a single publication of this message, as if we are sending the truck and not the 3 cars. So how can we do this? I'm going to copy this to RV's publisher using marker arrays, okay? And I'm just going to adapt. So in our imports, we will definitely need also the marker array. Now, here, our topic is where, so now since we are sending marker arrays, let me call the topic marker array. That's the topic name. And our message type will be marker array. Okay, so this has to be changed. Now, when we are building the message, we build 3 markers separately and then we publish them. So instead of building and publishing, we are going to build and append to the list, and then we publish the list. So first we start by creating our marker array. Create the marker array. That will be marker array, marker array equals marker array. So I'm just using the same logic as I did below on line 33, where I was defining the marker based on the marker, instantiating a new marker. So here I'm instantiating a new marker array. Then I go and define my new marker. That's okay. And in the end, instead of publishing, I'm going to say marker array dot, the field of the marker array are the markers, dot, the markers are a list. Why do I know that? Because there is brackets here. So they are a list. If they are a list, they will have the append function, which allows me to append a new element to the list. And this new element is the marker I've just created, not maker marker. Okay? And now I don't need to publish it. Okay, now we go into the cube marker. It's the same, and in the end, I don't need to publish, I need to append it to the list of markers. Oh, sorry. Now, finally, on step 3, I am going to do the same. So I'm going to append to the marker array, and I don't need to publish. And that's it, right? Right. Now you are very well. What's happening with you? You are all very attentive today. Publish the marker array. Right. Oops, sorry. Publish, and this is the marker array. Okay, so now if you run this code instead of the first one, no, sorry, if you want to run this code, we want to run this using what? I did a space here. No spaces in codes, always underscores. Okay, so using Emma. Okay, so we are going to reset our views. So now we don't have. Perhaps it's lost. That's strange. Okay. This is not what we want. What we want is a marker array. Okay. And now our marker array will be on a different topic name, which is called marker array. And now we have here the information. Okay. Now, what if the aliens go crazy and the ship starts moving, for example, rotating around its axis? So how can we do that? We can, in the orientation, right? So we are going to search for the marker which respects the sphere. Here we are. And now we need somehow to change this orientation. So every iteration of the loop, we are going to change the orientation to something. By the way, this orientation should always be a normalized vector. So this is not good. If we don't want to say anything, we should put 1 in the W so that the sum is normalized. But in our, sorry? You can what? Repeat? Ah, yeah, repeat. So what I'm saying, this must be normalized. Not must be, should be, because if it is not, it will throw out a warning. So this vector must have a norm of 1. Okay. That's why I'm putting there a 1 in the W. And right now, what we are going to do is we are going to change the value of an alpha. Let's call it alpha equals, let's call it angle equals 0. And now we can have an angle increasing every time. Okay. When the angle reaches, let's say, some value of, well, let's say 1. Let's say it starts with -1, and then when it reaches 1, it goes back to being -1. Okay. It's just going from -1 to 1, then -1 to 1. That's it. Then this orientation, if we want to rotate this, let me show you the coordinate system here. Axis. So you can see the coordinate system here. The X is the red. So if you want to make this rotate around the X axis, we have to do we have to change this orientation around X. So here we can put the angle. Okay. And now, since we are looking for a normalized vector here, well, we can just put a 0 here. I think it will normalize automatically. It should be normalized, but let's forget about that part for now. To do should be normalized. Should be a normalized vector. Okay, but I think that will be enough to see some movement. We can try it. Angle. So should work. Something is failing, not sure what. Let's try again. What is this one? Yeah, you see here the warning normalized quaternion. Normalized quaternion. For the 0, yeah, it's complaining that it's not normalized. Okay, so let's try to normalize it. We have the, so this angle, I think it should be something like 1 minus the angle, no? Que a norma tem que ser 1 igual a raiz quadrada de 1 mais 1, portanto é 1 ao quadrado, menos este ao quadrado, angle. I think this is it. I'm not sure, but I think this is it for the normalization. Let's try. Okay, now it's moving. Okay, so you can see it moving. Now it doesn't look like an alien spaceship. It looks like a windmill, a turbine. So it lost a bit of the, but it's moving. Okay. Now, how can I make the red cube? Well, first, let me put the red cube on the bottom plane. So this is a red cube, and it's going to be on z equals 0. Okay, and now what I want is for the red cube to be moving around the circumference. So it's like doing the trace of the circumference with radius 2, let's say. How can I do it? You can help me. Sorry?
Polar coordinates.
Polar coordinates, okay, but you have to tell me the actual code. What, where, and what should I write? Okay, so first let's find the cube, which is here, right? This is not the cube, this is the text. Yeah, this is the cube. Okay, so the x, sorry, the x and y are this one, these two. So what do we do with them? Okay. Radius equals 2. Which is?
X0 plus
Radius, radius times math dot cos of angle. And for the y, it's the same, but with the sin instead of the cosine. Right? So from polar to Cartesian coordinates. I think that's it. Let's try. Okay, here's our, here's our cube. If you look from top down, it's actually, well, yeah, you know what's happening here?
Yeah, because the angle is on the.
Yeah, the angle. So we are using this angle, so we would need a different angle. Let's call it alpha. Alpha equals to 0. And now we are going to use something similar to this here, where we pick up the alpha. And if we increase it, and if it's bigger than math.pi, we go back to 0. So now we are going from 0 to, no, p to pi, right? So that we can go complete the full circle. Okay, let's try it. No, this is missing still. Alpha, okay.
And they kept going.
I think so, because this alpha, this sin and cos functions actually they have no problem with it. So yes, we can do this, I think. Let's see. It works. Okay. By the way, my normalization of the quaternion is still not working properly. You can see there at some point it fails. Okay, but that's not my focus. So I just want you to try to do something else, which is let's change the color of the text. And I want to change it randomly. So I want the text to be in one iteration with a given color and with another with some other color. How can I do that? We go back to the code. So the text is here. How can I do it?
We use random.
Yeah, random generation on which line?
We can already put it after the color dot R.
Exactly.
We want to use a different value for each one of the.
Exactly. So we have to import the random.
Then we have to define the range.
The random is already between 0 and 1, so it's okay. We are lucky in this case. So if we go here, okay, now it's changing color. What if you wanted to change color every 2 seconds? That's trickier. What could you do?
We are publishing one errors. We use a counter.
Okay, without knowing that. Yeah, you could use a counter, but without doing that.
Is there a way to use a different publish rate for?
Maybe use the time.
Yes, the time, I would say the time. So I would do something like this. We are going to define the color. So let me call a variable. Define the initial color. Initial color. And what I'm going to do is to define the R. Well, let me mark this one and then go down here and mark this one so I can go back and forth without problem. Yeah. So let's define a color. Color equals color. Well, we know that color is a, let me go back. We know that color is a standard message color RGBA, so I'm going to import it so I can use it. From standard messages, std messages.msg, import color RGBA. Okay. So now I can say color equals color RGBA. And now I'm going to import, to randomize, sorry, my initial color, color.r equals random, not random, not like this, like this. Dot alpha is always going to be 1. Oops, now. And now R, G, and B. Okay, that's it. Now, this is going to trigger the initial color. Now I need a tick. What is a tick? Is like someone looking at the clock and saying, okay, now is the time where I defined my color. So I'm going to do a tick. Let's call it color tick, which will be the time in which I've initialized my program, in this case, defined the color. So, cross by time dot now. This is the time now. Okay, now what should we do here when we are drawing the text? Exactly. Divide seconds to see if it's what? No, because that's for the particular case where I want to change every 2 seconds. But let's say I want to change every 7.35 seconds. Okay. So what I'm saying is this is a more general solution. So if by the way, before checking this, what I will do here is I will always set the color of the marker to my variable color. That's it, right? But here I will do, like Miguel was saying, I will do a check to see if my time, if the time since when I define the color has passed more than some seconds. So I have to compute what is called the duration in ROS, and I have to do a ROS pi time dot now. So this is the time right now minus the time when I set my color. That's my color tick. So this is a duration which we can put to seconds. So we can convert to seconds. 2 seconds. I never know if it's 2 seconds like this. I think it's 2 seconds. Yeah, like this. Okay. So my duration is now in seconds. So now if my duration is bigger than 2.34, that's my threshold, just so you don't think about using counters or dividing by 2. If my duration is more than that, what do I need to do? I need to re-randomize. So color dot R equals, well, better copy from a 3 young, sorry? Just so it's not an integer number and you don't think about dividing by 2. And Miguel was also suggesting doing a counter, because we know it's 1 hertz. So if you want 2 hertz, something like this. Okay, so I can't avoid you thinking about this. So, okay, better. Time, duration to change color. Okay, Robert, tell me a number. Yes. 25. Well, that's unpractical because we'll be 25 seconds waiting for the change. How much? 2. Okay. And duration bigger than duration to change color. Okay, and if that's the case, we randomize. If that's like this. Yeah. Okay, that's it. Let's see. So every 2 seconds, oops. What did we did not do? Yeah. So we have to tick again. So we have to say, okay, now the tick is this new moment where I just changed my color. Okay, every 2 seconds, the color changes. It's better like this. Okay, any questions? No questions? Okay, so let's go to the next exercise, which is a bit harder. I'm trying to, yeah, first things first. The first thing I want to do is to create a new ROS package for this, okay? So let me copy my 10, copy path, CD here, and now cat in create package, PSR 22, P2 part 10, exercise 8. This will be dependent on ROS file, standard messages, and since we are going to use laser data sensor messages, and we are also going to use the visualization message. Yeah, 8. Okay. Visualization messages. Okay. Now, for starting, we can use. I'm just going to copy this exercise. Well, better still, let's first understand what we need to do or what we want to do, the goal. So the idea is to implement a ROS node that will receive a laser scan message. You remember the laser scan messages from the first exercise. So these are the laser scan messages. And what the node should do is to create clusters. What are clusters? Let me try to draw. I forget to go in just a moment, okay? So clusters are groups, and clustering is the procedure by which we create those groups. And in this case, you are seeing the scene with a LiDAR. Well, actually, you can look from top down. And the LiDAR is there in the coordinate system. And you can see that the LiDAR is observing multiple objects. And the goal here is that we try to split the data into different objects or obstacles, okay? And for example, if we take a look at this data, we could say something like this. Okay, this object here is probably going to be, this data right here is probably going to be belonging to a single object. Then, for example, this data here should be a different object. And this one here is also a different object, okay? So we have different objects because they are separated in Cartesian space, so they are not connected. If we have disconnected stuff, those are different objects. That's our assumption. So how can we use this assumption in order to try to figure out which are the objects that we want? Let me draw some stuff there in the board. Okay, so now in order to standard, what we have is an X and a Y Cartesian system. And so our measurements will be from angle 0, which is this one. So this is theta equals 0. And then, for example, for theta equals 10 degrees, it will be like this. And so on. So we will have several measurements. Suppose that we have a scene where we have here an object. Let's say it's a wall. I don't care what it is. Then we have here another object. And what you are going to do if you try to measure is you are going to send a beam on, let's say, theta equals 10 degrees, and you measure this. So this will be your measurement 1. Then you send another beam very close to it, and this will be your measurement 2. And then your measurement 3. Well, let's start with 1, 0. Yeah, let's start with 0. And 3, and let's say now the measurement 4 will be this one, measurement 4, and then you have in measurement 5, and so on and so forth. Okay? So, when you go from one object to another, you can think of the n0, n1, n2, n3, n4, n5. And you can think of the theta and the radius. Okay, so let's try to put some numbers here. The theta will always be consecutive. So something like 0, 1, 2, 3, 4, and 5 degrees. Okay, that's just let's call it degrees. Let's compare. For the radius, let's say that it is implied. Let's call it 5 meters. For the 0, 5 meters, 0.1. 5 meters, 0.2. 5 meters, 0.1 again. And then when we go to 4, it is going to be much larger. Let's call it, let's say it's 8.5. And then for number 5, it's 8.6. Okay? So if you take a look at these measurements, what really changes when you go from one object to the other is, so radius changes. So what we need to do, we need to figure out a way to split these measurements into different groups. So what we really want is to somehow do this, right? I'm going to put here another option, for example, here. And now we have here, for example, our measurement 6. measurement 6. It will be a radius of 6, and in this case, it is going to be much shorter. Let's call it 4. Okay, so, and so now, before we know how to do it, not before, but what we should think now is how to organize this equation. I mean, even if we can find a way to have these groups, we have to figure out a way to store this information. So we are going to generate new information, which is this measurement belongs to group red, this measurement belongs to group green, and so on and so forth. We need to find out a way to store it. So I'm going to create a vector of clusters. So this is going to be a list. It's a big list. And it will have several clusters. But for now, it is going to start ending. Okay, so it's a list. For now, it's ending. Inside, it will have each element will be another list. So here we will have another list. Let's suppose now that we have only one cluster because we have a single list and a single element, which is a list, and then inside each cluster, this will be a cluster. Or if you want a single, we will have indexes of points. So, what I really want to get is the first cluster, which I'm going to paint in red, contains points 0, 1, 2, and 3. So I would like to have this. The second cluster, which I painted in green, is going to be a second element of these clusters and contains points index 4 and 5. And finally, the third cluster will only contain a single point, which is index 6. Okay? So this is the list of indexes of the point, right? So that's what we want to generate. That's how we are going to represent the information we are going to generate. Now, how do I suggest we can do about this? Depends on how we do. What we can do is we can start. So let's do it from the beginning. Okay, so from now, the cluster can run. Now, what I will start is I will say, okay, by default, my first measurement, my index 0, is going to be on group 0 on the first floor. So I'm going to create the cluster and put there the value 0. That's it. Okay, this is just by definition. Now I'm going to start iterating over all other points. I'm going to start with this and this and this. For each of these points, what I will do is I will measure the distance between the radius of this point and the radius of the previous point. So I will do for this the radius of 1 minus the radius of 0. And this must be done in modulo. And this must be below the given threshold, which let's say the threshold equals 0.5 meters. That's how separate the two measurements must be in order for me to believe the identical. So if R1 minus R0 is smaller than R2, then I believe that I'm still within the same group. So if when I start trading on 1, I will do 5.1 minus 5, which is clearly below my threshold of 0.5. Therefore, that means that M1 belongs to the same group. So in this case, what I must do is I must go to the last group that I have in my clusters. It's only one group, so the last is the first. And add the new index to the list that already exists. So I will append to this list my number 1. Okay? Then I go to the second point. For the second point, I will do the radius of the second point minus the radius of the first module. smaller than 0.5. That would be 5.2 minus 5.1, it's still under 0.5. That means that my option is going to be, again, believe they are in the same cluster, and therefore, append to the last cluster that exists, that's the first, a new index, in this case, number 2. And the same will happen for number 3, because I will get you 5.1 minus 5.2, that's still under 0.5, that means I must do this. Okay? When I get to the 4, I will do minus R3 under 0.5. Okay, R4 is 8.5 minus 5.1 minus 0.5. This is false. Okay, so if this is false, I know that I must create a new cluster. So what do I do in order to create a new cluster? I will create a new list in the clusters list. And I will append to that list the new, the index of my point, this case 4. Okay? And then I go to the next point. So when I get to 5, I will do 8.6 minus 8.5. That means that this math will be true. If it's true, I have to do what? Go to the last cluster. Now that's not number 0, that's number 1, and append the index of my point. And so on and so forth. Okay? So that's the outline. Now the implementation. Any questions, by the way? No? Now the implementation. The implementation can be something like this. First, where do we start? We want to receive the laser scan messages, so perhaps the best is to start from our exercise 1, right? So let's pick up exercise 1, which is not here. Here, okay. Okay, so we go to source. Here is our subscriber. We can put this into source. We create a copy. Let's not call it subscriber. Let's call it LiDAR clustering. Right? And okay, so what did we do before? We had a publisher. Okay, let's not care about this publisher. Then we had a subscriber. This subscriber was subscribing to the laser scan. And when a message was received, we would say, I received the message, and then we would create a point cloud, which we would then publish. So let's just see if this works, okay? So what we need on this side, we need first raw score. Second, on the left-hand side are these. Third, we are going to replicate, so remember for exercise 1, let me show you, we needed to download a bag file which we would play. So I'm going to replay that bag file again. So in my case, it's in the desktop, and I'm just going to do ROS bag play of the LiDAR example minus L. So this is just playing over and over again the same information. And actually, if I go to RVs, I can already see it because it was already configured. So let me just always on top, this more to the right. Okay, so here's RVs, okay? And here is the data for the laser subscriber. Why are we already seeing this? Well, because I already have here my laser scan configured to the left laser scan topic, okay? So that's the information that we have. Now, if we put our code running, so ROS run PSR 22 P2 part 10 exercise 8 LiDAR clustering. If we do this, it's printing I received a new laser scan, and it should be publishing a point cloud. Let's take a look at this point cloud. Add point cloud 2 plot squares Well, spheres. The topic is going to be this one. I think the spheres are too small, 0.6. Yeah, now they are too big. And we can just change their color, something like flat color, green. Okay, and with some alpha, we can put some alpha, 0.3. Okay, so you can see here that, well, this is exercise 1, right? So we are publishing the same information that RVS is drawing automatically because we are doing in our code the conversion from polar to Cartesian coordinates. That's what we did in exercise 5 last week. Now we can start from here and we can do the clustering whenever we receive a laser message. Okay, so we will not use this point called publisher, so I can take it away already. Let's just take it away. And yeah, the publisher, we will leave it. And now we just need to do the clustering of the laser scan message. Well, I just take it away, but I will need to get some inspiration from this part. So I will not delete it, I will comment it. Okay. Now, yes, so publish the cluster the laser scan message. So we know the algorithm, we just have to implement. So remember, the first point or point number 0, we will just define. So first, before that, our clusters, that's the list of clusters, is an empty list. Lists of point indexes. Now, to get started, set the first point as the only index in the first cluster, right? So clusters dot append, I will append a new element to the cluster, which is a list containing only the index of the first point, which is 0. Okay. Now I need to iterate over all the measurements. So you can, that's why I didn't want to delete this part, because this part is the part that iterates over all measurements. Okay, now this part here is iterate over all points and decide when to change to create a new cluster. So I'm going to start iterating. The alpha I don't need. I need to compute the R of the index of current index. So that's the ranges in my message for the index, and I need the previous R to do the comparison there. So R previous is the ranges of the index -1. Yes, of course. You need to start at 1 instead of 0 in order to be able to go to the previous one. Then, after this, we have to make the decision. Either we will not change group or change group. So if our absolute, that's the modulus that you see there, R current minus R previous, if this is smaller than, let's create a threshold here, threshold equals 0.5. Okay, if this is smaller than our threshold, it means that this point belongs to the last group, right? If it's not, it means this point is from a new group, right? So when it belongs to the last group, what do I need to do? I need to go to the last group of the clusters, -1 is for the last element of a list, and add to it the index of the current point. So that's when I only have 0. And when I go to one, I say, okay, one is if we go to last element, this is last, and put there 1. So that's what I'm doing here when I do append index. Okay. Now, for the else, I'm going to have to create a new cluster. So I'm going to have to append to the clusters list. So I have to create a new cluster. That's when I go to 4. So when I was in 4, this was all. I already have one like this, while I can come with my new element. So I am going to append. So clusters not append. And what do I need to put there? I need to put a list containing only the first element. Oops. Index. Okay. Does it make sense? Any questions, anyone? I know it's not easy, but it makes sense, right? Okay. Well, now let's see if it works, because if it doesn't work, that would be a lot of work for nothing. Let's see. Right. Yeah, there are several ways we can see it. That was my next discussion. The first one is this one. Okay, so let's just print it. So if I run this, and you can see, and I run the code, you can see that here we have 2 square brackets. So that means it's a list. Well, here a list of lists. That's why we have 2 there. And then we have the first element, which is composed of the indexes 0, 1, 2, 3, 4, 5, 6, 7 until 8. And then we start a new list, a new group, containing only number 9, and so on and so forth. Okay? Makes sense. Now, how did I run the bank? So so first I have to go to the file, right? To the folder, then hard back space play, the name of the bank, space minus L for loop. Okay, so the print works, but of course, as Miguel was saying, this print doesn't really help a lot because we just see a bunch of numbers on screen. Now what we have to do is to try to not try, we have to publish visual information that shows us which are the clusters. And perhaps the best way to do that is to do what I was doing before, manually. So is this one cluster? Yes, it is. So why don't we just publish points in green color for that one? This is another cluster. Let's publish points in blue color for this. And this is another one. Let's publish in red. Okay. We are just publishing the points with the color of the group. That means we need to publish points. We did publish points before, we published a point cloud, but in this case, I want to publish a marker, an Arvis marker. So we have to go back to what we were doing and see that we can also publish, let's say, a list of cubes or a list of spheres. Let's do a list of spheres, okay? We are going to publish a list of spheres. So how does it work? Well, we have to create a marker. Create a marker, visualization messages marker that will contain a list of spheres. Now, marker equals marker. Let's see if it imports automatically. No, I don't even know what that is. From visualization messages.message import marker. Okay, so now we have a marker. And we can even copy paste from the previous exercise. Here, where we were defining, for example, let's see where we were defining the sphere marker. So I'm just going to copy paste this, okay? Copy paste. So we can also define, so at least now we know which are the fields, and now we can just change them. Oops. Okay, so the frame ID cannot be world right now. It has to be the frame ID of the laser, left laser. The space will be my drawings, the ID is 0. The type will be sphere list and lot lists. We are going to modify. Let's not change the coordinates of the system. So this should be 0 and this should be 1 so that the vector is normalized. The scale of the sphere, well, 0.4, I'm not sure, but let's try. So now we want real spheres, not ellipsoids. And the color will be, well, for now, let's just have a everything in red. Just to see if this part works. Because it will not, we still need to add information about the several spheres that we have. So this was enough information to publish a single sphere, but if we want several spheres, how can we do it? Well, if we go to the manual, it says here that if we want to, here from the start, if we want to do a sphere list, what we need to do, a sphere list is a list of spheres, all with the same properties except their positions. Using this object type instead of a visualization marker array allows blah, 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 no interest. Then the points, so this is the field that we need to add. We need to add the field points, which is actually here. We didn't need it before, but now we are going to need it. So the field points is like you see here, a geometry message is dot point and the vector of those because of the brackets. So what we have to do is actually to iterate over all the points. So for now, I'm just going to iterate over all the points. Starting from 0. And for each point, I'm going to compute an x and a y. And for this x and y, it has to be, well, before, actually, I needed that part that I deleted. I can go fetch it. It's here in part subscriber. It was here, this part here. The conversion to polar coordinates, right? So I'm going to pick up my angle, alpha, then my radius, r, then I compute my x and y and z, and finally I can create a point which is a this point is a geometry messages point, you see there, okay? So I might as well include it. So from geometry messages, message import point. Why can't I find? Not geographic, not geographic, geometry. Geometry messages, dot message. Import point. Okay, okay, so this is just the import that I need, and that means that now I can do point equals point like this. So I create a new point, and all I need to do now is to add this point that well, first I need to populate this point, point.x equals this one, and point.y equals that one. So point.y equals that one, and point dot z equals 0. Okay, just defining the coordinates of the point. And finally, now that we have the point, we can go to the marker. Field points, it's a list, so we can append the point we created. Okay, let me just do something here. We go up there, put the import up there. Okay, so we are back here, and that's it. Right now, if we show this, it will publish the points, not the points, the spheres, in the same coordinates as the points, so centered around the points, with a color of red transparent for all the spheres. Let's check it. Color stress still without clustering partner. Right. So now we want to publish a marker, so we have to define our publisher correctly. So the publisher will not publish a point cloud, it will publish marker, or better, clusters. And it's not a point cloud, it's a marker. Okay, next attempt. Okay, so we don't need the point cloud now. We just need to, we have the marker there already. So, these are subscriber clusters. It was already the proper name. Okay, so you can see here the spheres with transparency around each point in the data, all red for now. Now, what can we do in order to change the color? Yeah. For each point? Yes, we can change the color by point by filling up this colors vector. So if you read the manual here, it says in visualization, blah, blah, in the last version, it is also, we can also use the colors field to specify a color per sphere. So what we can do now is to create a color. So we need to import from standard messages.message, import a color RGBA.
You have not given information about the clusters.
Not yet.
Okay.
So we import this, and this import should be up there. So I'm just going to copy paste it up there. Okay, so now we know that we can use a color. So now we're just going to define a color RGBA, a color variable, which is the color RGBA. Well, you can check what color RGBAs have. I will show you. So color RGBA will contain an RGB in the data. We've done it before. I forgot. I never know what okay. And so we can say, actually, I will tell you a new trick. Instead of doing here, color.r, blah, 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 we can do it here. R equals, let's do random for now. G equals random dot random. B equals random dot random. A equals 1. Okay, so we have a new color. Now all we have to do is to append this color to our list of colors. So marker dot colors dot append color. Sorry? It's not the same. Marker dot color is the field color of the variable marker. So I can define here. Okay. I know what this is colors in plural, not color in singular. Okay, different variable. So because that's the color for all the elements, and these are the colors per element. Okay? Yes. Yes. If it exists, it does. No? Yes, the vector colors must be the same size as the vector point. If it's not, it will break. So what we expect to see here is points with random colors. So everything is changing. This I call the rainbow art. Okay, so here's a bit of rainbow art, okay? By the way, we forgot about the alpha. So this alpha should be 0.3, for example. And now rainbow art with transparency, okay? Now, the question from Miguel makes sense. We are still not using the information that we created about this, about the clusters. So that's why we have no connection between the color of the points and the clusters, of course, right? So now we have to do some connection. And how do you propose we do it? Okay, and we could do that. Or we can just have a color which is randomized, and then whenever we change cluster, we randomize again. But perhaps we can do it like that. Let's create a list of. I'm thinking. The option is you can either create a vector of colors, so you can anti-marking this. You can also create a vector of, let's call them, what's the colors? Or not. Microphone on, sharing screen again. And as I told you, we are now going to try to create this vector of colors. So whenever, well, this vector of colors can have can be always fixed. So let's say that in as a global variable, or yeah, let's do it here, no problem. So we are going to create a vector of colors, or a list of colors. Notice we don't know how many clusters we will have, so let's just say we create a list of 200 colors, assuming that it's not possible for us to have more than 200 groups. So let's create a list of colors. What we can do here is to use something called color maps. So you can go to a color map in Matplotlib. I was hesitating because I didn't know if I wanted to show you this now, but okay, now that we started. So how can you use a color map in Matplotlib? Let me check. A color map is a way to have a variable that changes value paired or mapped to a different color. So for example, if you want to change color from a variable that goes from 0 to 100, and you want to change it from black to yellow, you use color map hot. If it goes from pink to yellow, you want to use color map spring. It's just a transformation from a value or a range to colors. It's a mapping. That's why it's called color map actually. And I did it. I did this this week on PSR, didn't I, Eugene? I think I did. My memory is failing. Not PSR, Savi. Didn't I do this in Savi this week? You were there in Savi, weren't you?
It's from.
Yeah. Let's see, exercise 1, main. Didn't I have a color map here? Or perhaps I'm completely find color map. No, search again in all files. Yeah, here. Ah, I did it. Yeah, plain segmentation. Yeah, I did it. Ah, no, it's for next week. I was preparing for next week. Okay, I remember. Copy. Okay, let's create a color map. So what is a color map? A color map is this map of colors. And we just import a CM from matplotlib. So let's see here how I did it. The CM is imported here. Here, let's copy it. Copy. And paste. Okay. Oh yes, so NPy is NumPy, come on. From import NumPy as NP. Okay. And now I just want to go from 0 to 200. Let's say that we cannot have more than 40 clusters, let's say, or 50. Okay. So we want to create 50 colors, 50 different colors using the color map pastel. And so we should be expecting to see something like this. Where is pastel? Pastel here, something like this, okay? So the first group should be red, the second blue, the third green, and so on and so forth. Okay. And what is the myCM? Let me show you what it creates. Print myCM, exit. So after we print, we just abort. So the myCM will create a NumPy array with 50 colors. So yeah, 50 is too much. So just for visualization, I will put here 5. And if I run it again, you can see that it just printed 5, a matrix with 5 rows. Each row is a color and 4 columns. Each 4 columns is the R, G, B, and A. Okay, so these are just the colors that I want to use in the color map for each group. So now I have my CM. I can use it. How? I can just go. Well, I don't even have to. Yeah, I don't have to create this list. I can just use this myTM. It's the NumPy array. So when we are here, iterating over each point, we will know if we should use one row of the myCM or another. That means one color on another, depending on if the point belongs to one group or the other. So we have somehow to figure out to which group the point belongs to, right? So what I'm trying to go to search for is the cluster index. So this group belongs to which cluster? Which cluster? So I can do that by doing this. For cluster in clusters. So I'm going to iterate over all clusters. That means I'm going here, then here, and so on and so forth. On each cluster, I will check if my point index, IDX, is inside the cluster. So this will allow me to automatically know if the point exists inside the list of that particular cluster. So if my index is 2, what I will do is pick up the first cluster. If 2 inside this list, get it true. If it's true, my cluster index okay, so now I have here to have my, I need to account here, count equals 0. Now here, count equals count plus 1, count plus equal 1. So this count is the let's call it the cluster count. Okay, so I'm just doing, I'm starting from the first cluster, so my cluster count will be 0. I see if my point index is inside the cluster. If it is, my cluster index is the cluster count, and so on and so forth. Okay. Then, now that I have my, well, by the way, when I find that my point index is in a group, for example, if I search the first group and my index is 4, I search the first group and I don't find. I search the second group and I find. I don't need to keep on searching. I call this people who, so you are home, you start looking for your car keys, you find them, and then you continue to search. Doesn't make sense, right? So if you find what you need, you don't need to continue to search. So we do a break. Yep.
So if you have already set the first filter, the next one will never be the first.
Yeah, that when you are searching for the car key and you look in the closet, you don't look again. Yeah, but yes, it's true, we can do it, but it's more complicated, and I want to do it in another way next. So we do the break just so we stop searching because we know that we are not going, we already found. And now here, finally, we are going to get the proper values. So now we are going to have to go to my color map. And I told you this is a list of several rows or lines. And the line that we want depends on the index of the cluster. And then the first column will be the value of R. The second column will be the value of G, and the third of B. Okay? So R equals R, G equals G, delete until line, B equals B, delete until line, and alpha is always 0.3. Okay? So that's how we get the color from the color map. Get the color of the corresponding cluster. Okay? So if we do this, that's what we can see. Oops. This is in line. Index 6 is out of bounds. Yeah, I remember. 50. Well, better 255 or yeah. I want to make sure that I don't have this problem. Yeah. Okay.
Wasn't like this. Okay, well.
Something is wrong. Everything is green. So something didn't work here. Here. Cluster RGB, cluster index. RGB. Let me print here. Print. Point. Sorry. Point index equals point index plus str index belongs to cluster str cluster index. Let's see if this makes sense. Let's see. So point blah 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 belongs to 56, then 57, then 60. It makes sense. So it seems that it's finding properly the cluster to which a point belongs, but somehow we are not being able to.
Can I just give a piece of advice in the function?
Sure.
I learned on YouTube shorts that instead of using spaces and the plus signs, you can just use commas and you can space it wherever you want.
Ah, okay, thanks. So what you say is this.
Yeah.
Okay, no, I didn't know, thanks. Okay, so that's a very good help of what I didn't need. What I needed. I just say it's not painting the colors, man. I'm joking. 500. Print my CM dot shape. Let's see the shape of the color map, just to make sure it's working. Where is the shape of the color map? Ah, here. 500 times 4, yeah, makes sense.
Oh, there's a different color.
Oh, there are.
Is it possible that you used so many? Because around 500 is such a big number that the difference in color from one to the next is.
No, that depends on the type of color map. If you have what they call a sequential color map, you will have something like this. So the transition from one to the neighbor is very small, right? In this case. In the case of the pastel, not really. It's supposed to be what they call diverging color maps. That means that it is going to change what you are trying to highlight is difference between neighbors. So that's why I use this. And in principle, that should be, what? Sorry? We have the same colors, yeah.
You know, we have these two colors.
Yeah, only 2. That's very strange. Reset. Okay, we need to publish it. No, something is wrong here. Let's follow Enrique's suggestion. I'm not sure how many groups we have. We can actually print the number of groups. Let's not do this. And we can print the number of groups. So we can say print, not here, perhaps here where we do the clustering. So this is the end of the clustering. So we can report something like found. What is it? Comma.
Yeah.
STR clusters, len of course.
Usually the person don't need to do STR because the conversions.
Hey, again, you are helping me where I don't need. Search for the colors, man. I need to know what's wrong with the colors. So found blah 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 cluster, and now clusters. Yeah. Oops. Yeah, 50 is not enough because we found 61. Okay. So let's do 61 here, or let's say 17. Oh, now it's working. Yeah, perhaps Enrique was correct. Although it should adjust automatically, I don't think it adjusts because it's. Okay. Now I get it. Okay. So what's happening is, well, now you can see that the clustering is working. And what happens is that when you create a cluster, so a cluster, a map of colors will contain a set of colors. Let's say it will contain from let's say pink, then yellow, well, perhaps blue, yellow, pink, and red. So just a blue to red color map, only with 4 colors. When we say that we want a color map with 4 colors, it will create without any problem 4 colors. 1, 2, 3, 4 with this code for the color. But if we say that we want the color map with 8, it will have to replicate somehow. So what it will do, if it has this resolution, it will do blue, blue, yellow, yellow, okay, and in pink, red, red, right? Pink, red, red. So what we did was we asked for a color map with many, with a large size, with 5 pixels. And what it did was it placed the colors of the color map here, and then, no, sorry, not like this. The first 50 positions of those were all in the same color. Were all blue. So it did blue, 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 because then it would go yellow, 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 yellow. And so the first 50 positions were all in the same color. And although our color map was size 500, we actually only had some 50 groups, and they were all invaded with the blue color. Okay? So we were writing something like what you now, what time is it? Yeah. Homework. For home, what I want you to try to think of is, look, now we are clustering, no problem. You can see that this object, for example, where I have my hand, is always of a different color from the other objects. So that's okay. We are doing clustering and it works. Now, what is really not so interesting is that the same object is always CG color. Okay? So what we could try to do is to find a way to make colors more or less stay fixed on the same objects. So for example, this large object here where my mouse is, if it was always the same color, that would be best, instead of now being yellow instead of brown, right? Sorry?
Are the same from question.
No, because the data changed. Yeah. So somehow you need to associate. My suggestion, well, that's a long discussion about tracking. You can ask Gino how it works from Savi, but the association part, we don't want to go into details or very complex details. We're just going to use one simple trick to try to make the same cluster have the same color. How can we do that? We can sort the clusters by number of indexes. So we can pick up the largest clusters and say the largest is always going to be red. The second largest is always going to be yellow, and so on and so forth. So if you can do that, in principle, the clusters will maintain more or less the same size. So their ranking area by area will always be more or less steady, and therefore the colors will also remain steady. I'm not sure if you can visualize how you can do that, but you will have to take a look at. Yeah, you have to take a look at this side. This is the little problem because it has 4 elements. Yeah. Yes, you do a sort of this, but you need to do more than that because we were coloring by iterating over the points. So we were going from each point. So what we were doing is this. Go to the point, try to figure out if 0 is in the first, second, or third group. It's in the first. Okay, that's red color. Go to the second point, try to find out. So we are going from points for each one of such group. If you do this, which is somehow to sort it, I think so, it will be better. We iterate over the clusters, and then for each cluster or for each index in the cluster, we have the I will do that. And it's easier to use the sort. Okay, that's for your homework. See you in some, not next week. Eric, your question.
It was about when we place the tag.
No, not that question. Before you go, the other question from this morning about doing a supplementary class.
Oh.
That question there, I'm not sure because as I told you, if I do it it is going to be, some people will not attend and I move forward and they can complain like, it's not an official lesson. So what I can do is if you want, you send me an email. And if I get enough if enough people ask, I can do a supplementary class in Zoom, something like this, just for taking questions. And
It was just because of the fact that we are losing 2 weeks,
Mhm.
and I don't know if you have prepared a material.
Yes, yes, yes.
In regards to those weeks being lost.
I will adjust. I
adjust.
adjust. What I will adjust. This year we have different final assignment from last year.
Okay, so it's better.
No, it doesn't matter. No. If I'm missing some time, then I will ask you for an extra class in January or something.
Okay, that's it. Agora, português só,
Sim.
do time, por causa da preencher as bases no passado. E ele estava a dizer que os dois têm aprender a trabalhar o tempo mais.
Não é.
Vai ser que tem que ser manual. Certo.
Fim de semana. Tchau. Tchau.